Okay, now let us go to the next topic, op-amp inverting amplifier. The circuit diagram for the op-amp inverting amplifier looks like this. As I have told earlier, op-amp will be having two input terminals. One is the inverting input terminal and the second one is non-inverting input terminal. The inverting input terminal is negative and the non-inverting terminal is positive. Now, as the name itself suggests, inverting amplifier stands for the input being given to the inverting terminal. So as input is given to the inverting terminal, we call it an inverting amplifier. This Vi happens to be the input. It is given to the inverting terminal via a resistance R1. So as input is given via a resistance R1, we call it input resistance, across which the current I1 will be flowing, and the next resistance is RF, which is called as the feedback resistance. The feedback is given to control the behavior of an op-amp. Feedback happens to be a part of output which is given back to the input. Now, you can be seeing two voltage potentials. One is V1 and the second is V2. V2 happens to be the voltage from the non-inverting terminal which is being given to ground. As V2 or the non-inverting terminal is given to ground, V2 will become equal to 0. If V2 becomes equal to 0, we shall continue now. There happens to be some information about virtual ground that you are supposed to understand now. Virtual ground is a concept in which a node of a circuit that is maintained at a steady state or a steady reference potential without being connected directly to the reference potential. And most of the times the reference potential is considered as the surface of the earth, or it is called ground or earth in general. So usually if this terminal is being connected to ground and this terminal will be virtually connected to ground only, and though it is not directly connected, we will consider this V1 to be connected to ground potential only. I'll explain how. V2 is however equal to 0 because it is directly connected to ground. Because of the virtual ground concept, V1 and V2 become equal. If V1 and V2 becomes equal, then both will be equal to 0. If these become V1 becomes equal to 0, there is no provision of the current flowing to enter into this. That is why the current will follow the feedback path. If current follows the feedback path, the current flowing through R1 is I1 and the current flowing through RF is IF. These both will become same because they happen to be the same current which is flowing in the circuit. So I1 will become equal to IF. Now let us try to understand what is the value for I1 and what is the value for IF. I1 happens to be the current across the resistance R1, which is surrounded by two voltage potentials. The first voltage is Vi, the second voltage is V1. In between these two, the current that is flowing is called as I1 across resistance R1. That is why if I try to write the equation for I is however V upon R. So the V happens to be Vi minus V1 divided by R1. So it is I1 is equal to Vi minus V1 upon R1, but V1 value happens to be 0. If we put it that in equation, it will be Vi upon Ri or R1. So this is about I1. Next, if I go to IF value, IF happens to be situated in between again two voltage potentials. The first voltage is V1 and the second voltage is V0. Now if you try to write the equation for IF is the current across the resistance RF. That is why the equation is V1 minus V0, V1 minus V0 upon RF. So now the equation is V1 minus V0 upon RF. If we try to put the value for V1 here, it is 0, and that is why the answer is minus V0 upon RF. Let me now continue to the next. So, however, we already know that the equation is I1 is equal to IF. Now that I know the value for I1, I know the value for IF, let us try to equate these two. If I try to equate these two, I'll get the answer Vi upon R1 is equal to minus V0 upon RF. If this I'll try to rearrange, I will get V0 upon Vi is equal to minus RF upon R1. V0 upon Vi is, as already told, is nothing but the equation for gain. Gain is represented by the term AF here. AF is nothing but gain, or it is called as closed loop voltage gain. We call closed loop because of the feedback that we have considered. And when we notice the circuit happens to be connected in such a way that the feedback is given to the negative terminal. That is why, and feedback is given to negative terminal, input also is being given to the negative terminal. That is why the answer happens to be in negative. The answer that we have got here is AF is equal to V0 upon Vi, which is equal to minus RF upon R1. If it is RF upon R1 and a negative sign, that negative sign implies that V0 and Vi are of opposite polarity, which means if input is like this, if this is Vi, then V0 will be of opposite polarity. This happens to be V0 now. This is about the inverting amplifier.